Welcome, everyone. This is Steve Woolidge with Arcadia Data. It's the top of the hour. We're going to get started just in a minute here. The way this system works is people are going to have to log into the browser right here at the top of the hour, so just give them 1 minute, and then we'll get started. Thanks for joining. All right, looks like we've got a quorum here. Today's session is how to scale BI and analytics with Hadoop-based platforms. I'll be your host. This is Steve Woolidge. I work with Arcadia Data as the VP of Marketing. And I'm really excited for this topic because I've really seen a shift in scale-out architectures primarily around data storage. And I think the movement now is around how do we get analytics and value out of those systems with scale-out BI and analytics platforms. So that's part of what we'll be talking about today, and I'm really delighted to have two great presenters with us today. Our special guest is Boris Evelson. He's the Vice President and Principal Analyst serving application development and delivery professionals, who is a leading expert in business intelligence. He's worked with Forrester for a number of years. I've worked with him over a lot of those years, and I really like working with Boris because he also was a practitioner early on in his career, deploying data warehouses at places like Citibank and being a strategic advisor at JP Morgan Chase. So he really understands the technology in addition to the application. And then we've also got Priyank Patel, who's the co-founder and chief product officer here at Arcadia Data, who's instrumental in the development of our product and has a rich history in analytic databases at companies like Aster Data and Teradata. So with that, I'd like to just get a little level set with the audience. Today we're going to start out with Boris talking about systems of insight and this shift that we're seeing in next generation BI platforms that scale natively with Hadoop and other scale-out architectures. And Priyank will get a little bit more into Arcadia and how we tackle that problem, and we'll have some time at the end for Q&A. In addition, we'd like to run a little poll now just to level set with the audience of where you are in your big data journeys. So hopefully you can see a voting tab that will pop up here, and we'll try and show these results in real time. So go ahead and I'll read the question out loud just as you're looking at it, but we're asking, where are you with your big data deployment? Phase A could be gathering knowledge, just thinking about Hadoop or other scale-out data platforms, or maybe you're developing your strategy, defining the architecture, selecting tools. Maybe you're piloting and got a system up and running, or maybe you're in a deployment phase, you're actually using your data platform and using analytics to give end users access to the systems. If you could select any of those choices, that would be great. We'll just give it a couple seconds here for people to respond. And I guess, by the way, while you're doing that, we'll also take questions throughout the session today. There should be some tabs on your right-hand side that you can see where you can enter in questions as we go. Okay, so you should see the results at the bottom of your screen as they're streaming in real time there. So it looks like 50% of the people are gathering knowledge. We've got some people that are deployed, and it's shifting here as I talk, and we can share these results back with everybody as well. We'll probably do a blog wrap-up at the end. Thanks for taking the time to fill that out. All right, so we'll move on then, and I'll turn things over to Boris Evelson to talk about what's happening in the market. Boris?
Excellent. Thanks very much for the introduction and for the opportunity to present. Yes, indeed, you are correct. I've been in this market for over 30 years, I think about 35 years at this point, last 10 years at Forrester, and I'm really, really happy to see what's happening in the market because finally, after many, many years of trying to instill the discipline of running business by the numbers, by data, decision-driven company, business models are finally beginning to become a reality. So great data points proving what I just said. This one is from Morningstar. It is predicting that in the next few years, insights-driven, so we now like the term insights-driven as opposed to data-driven, because obviously data is just bits and bytes. You can't look at bits and bytes and make decisions. So BI and systems of insight that I'll talk about in a second are really all about transforming that raw data, bits and bytes, into meaningful, insightful, actionable information. So those companies out there that are going to be insights-driven are going to grow 8 to 9 times faster than their peers, 8 to 9 times faster than GDP, and obviously that's a huge chunk of change, not something that's easily overlooked. Some other very interesting numbers from Forrester. Basically, what's been happening over the last few years is that BI slowly but surely has been moving from the back offices into the front offices, basically morphing from being just about compliance or transparency or nice-to-have type application to basically a corporate asset that everyone is using to compete on. So as you can see on this data point, improving customer satisfaction and getting competitive advantage are at the top of everyone's agendas. And those of you, those 59% of you who tell us that BI is their top priority, are also reaping some very tangible benefits. So more than 45% of you tell us that you are today getting double-digit returns, tangible returns on your BI investments. And when we correlate your position in the industry as an industry leader as opposed to an industry laggard, and we basically define that as anyone who's growing faster than the industry average, the average within your industry segment. If you're growing faster, you also happen to be investing more than a third of your BI, of your IT budget into BI. So not only tangible ROI on individual BI investments, but also correlation between your BI maturity and your BI investments in your overall growth. But that road is not without challenges, and I'm sure all of you on the phone are aware what those challenges are. If I am pressed to talk about one single challenge, obviously there are multiple, but one single challenge is a disconnect between business and IT. Unfortunately, I see that all over the place today, and we on the IT side are definitely and unfortunately to blame for this, because a lot of IT professionals are still really stuck in the technology for the sake of technology conundrum, that we overly emphasize a streamlined data architecture and centralization of your BI organization, a single BI platform, and basically trying to get to that nirvana single version of the truth. And it's not that these are not important priorities. Absolutely, by all means, these are very, very important goals and objectives, should be top priorities, but not the top priority. We tend, unfortunately, often to forget that our business counterparts really just want to get their jobs done. So if they can get their job done with Excel faster and better than with your enterprise BI platform, then you know what, you didn't do something right. So that's a very important lesson learned, and I believe more and more IT and BI shops are beginning to embrace this. So as a result of the disconnect, as a result of a complexity of architecture that we bring in to achieve that version of the truth, we see some pretty bleak results. That on average you tell us that you all leverage less than 50% of your structured and less than 25% of your unstructured data for decision making, and these are self-reported numbers. We know that you are not aware of all of the data that's out there, especially external data, especially unstructured data. So more detailed studies, whenever we go in and we analyze the environment at our clients, we see even bleaker results, that less than 20% of your structured data and less than 10% of your unstructured data are being used for insights and decisions. And I'm sure this slide is near and dear to your heart. You know, no matter how long anybody on this phone has been investing in BI and putting out BI platforms and applications out there, Excel still rules. That's the platform that provides instant gratification. So about 2/3 of you still tell us that more than 50% of your BI content is sitting in spreadsheets and other homegrown shadow IT applications. So enough about the bad news. Now let's start talking about the good news. So what are some of the solutions out there that we think are going to help us get closer to that nirvana of highly efficient and effective BI environment in enterprises? And we at Forrester believe that the answers lie in these three areas. We'll leave the topic of artificial intelligence for a later time. This definitely warrants special separate discussion. Today we'll concentrate on the first two topics, extremely important topic between the business agility and big data capabilities. I think it is about 90% of the success, and AI is just going to be the icing on the cake. So let's dive into these two topics, business agility and big data, and talk about why they are so important. The reason that business agility is so important is because today we are at the age of a customer. What Forrester means is that we are way past the age of information, and we are in the age of a customer where customers rule. So I don't really care how your internal organization, how your internal enterprise processes such as finance, HR, supply chain, risk management, ERP, CRM, I do not really care how well-oiled those processes are and how well they run. If those processes are not allowing you to follow and embrace your customer behavior and address your customer behavior, you're going to fall behind. So we call that enterprise, the age of a customer. Enterprises are outside in driven as opposed to inside out driven. So basically there is nothing more important than following your customers and addressing their needs regardless of what your internal business processes are all about. And once we realized that a few years ago, we went out and we conducted some research where we decided to quantify what business agility is all about. So we came up with these 10 dimensions that you see on the right of this slide, 10 dimensions of business agility. And these are all common sense dimensions. So obviously, if your channels are integrated, you are more agile and responsive. If in the middle of this slide, your infrastructure is elastic and can shrink and grow, and you can provision and deprovision resources based on customer demand, obviously you're going to be more agile and responsive. And as you can see, BI is front and center, right smack in the middle of these capabilities, and some other capabilities here are directly dependent on BI, so market responsiveness, knowledge dissemination. And then what we did is we plotted business agility capabilities of about 350 public companies, plotting them on two dimensions. So their awareness of how well aware they are of these business agility capabilities and how well can they execute on these capabilities. And I'm sure you're already guessing what I'm going to show you on the next slide. Yes, you guessed correctly. Higher performers, those companies that grow faster than industry averages, that grow faster than their peers, are all over what we call the formidable category, right, in the upper right quadrant, meaning these companies are aware of the business agility capabilities and they can execute well, versus lower performers, industry laggards on the left side, are all over what we call the humorously, obviously, the clueless capability. They're not aware and they're not executing. So definitely, again, some quantitative proof of a correlation between overall business success and business agility. So then the next question is, what is it that we, BI professionals, data management, information management professionals, what is it that we can do to support these business agility capabilities? So again, a very long discussion. I'll just whet your appetite that we at Forrester recommend practicing this 4-part Agile BI framework. It is all about agile software development, where we emphasize rapid prototypes and rapid proofs of concepts put into quasi-production environments where business users can start using the systems within hours as opposed to weeks and months when it's already too late. The second component are agile organizational structures, where we realize that neither ends of the extreme in organizational structures work. So organizational silos are obviously not good because there are redundant resources and there is no single version of the truth. Everybody's getting different answers to the same question, but we forget to give silos some credit. Silos are much more agile, much more responsive than centralized organizations because they are, if I own my own development shop, if I own my own BI team and I don't need to share those resources with anyone, obviously I call the shots and I'm much more responsive to the market needs. And when we move over to the other side of the extreme where sometimes erroneously organizations overly centralize their BI support. Yes, they rationalize resources, but they now become highly bureaucratic organizations. They spend endless hours in steering committees and prioritization meetings, and as a result, they move slower. And when they move slower, guess what business and users start doing? They go back to Excel and homegrown applications. So we recommend some kind of a middle of the ground. We've got a lot of deep research behind that. I welcome everyone taking a look at it. Obviously, we need to practice agile BI processes. So, as I said, rapid prototyping as opposed to a long waterfall development cycle is one of the examples. And last but not least, obviously, what Arcadia Data will talk about later in the presentation, that you have to have an agile BI platform. If you have an older generation BI platform still used on older generation architecture, where it takes a long time to change anything, a long time to develop anything, that's not going to help in the business agility, in the environment where business agility is a top priority. So that's kind of a 100,000 feet overview of business agility and how agile BI plays an important role in that environment. Let's move to the second part, the big data, and let's talk about what role big data plays in this business agility equation. I typically tend to stay away from the multiple V definitions of big data. It's good to start the discussion about big data using the terms like big volume, velocity, variety, and variability, but it doesn't really, it's not really actionable. So, once we have this discussion on big V's with clients, they say, all right, well, what do I do with that now? How does it translate into some actionable kind of follow-up items? So rather than talking about multiple V's, we like to frame the discussion along these four lines. So rather than creating a definition of big data, and by the way, between 2 or 3 analysts and 2 or 3 vendors, when you get 5 or 6 people in a room, you're going to get 20 different opinions as to what big data is all about. It's not. So rather than defining it, let's just understand some of the use cases. So we have this 4-part discussion with our clients. The very first one is about people and processes, right? So all technology implementations have 3 components, right? Technology, people, and process. So if your challenge is in the people and process part, so if you are challenged with business and IT alignment, as I talked about earlier, if you're challenged with data and BI governance, if your challenges are data quality, that has nothing to do with technology, so please don't equate these challenges with anything that big data can help you solve and address. The second part of the discussion are all about upgrades. So if your system is running slowly, if you do not have the right architecture, maybe you're still using all types of databases, maybe you are still using IT-centric BI platform where business users are not really empowered to self-author a majority of their own BI content. Maybe you just need to scale up or scale out. You need to add some CPUs. You need to add some nodes in your service. So maybe it's purely a technology upgrade situation, which has nothing to do with big data. Then we do indeed dive into a deeper discussion where big data indeed has some legitimate use cases, and we'll do a deep dive into that on the next slide. And then once we kind of understand that indeed your requirements for big data address the real use cases, the real big data application. Then we talk to you about some of the implications when you upgrade to big data, when you upgrade to Hadoop-based information management, data governance, and single version of the truth and data quality become completely different issues. They still need to be addressed, but they are addressed very differently for reasons that we'll talk about in a second. So here's what's really behind that third point on the previous slide. So these are the really real kind of four areas of four areas of requirements which do necessitate investments in big data-based BI technology. So number one, your business requirements call for linear scalability, right? So we all know that even cluster-based BI platforms do not scale linearly. There are some databases that are based on massively parallel distributed scale-out technology, but if your BI platform is not based on this massively parallel and distributed technology, then obviously you're going to be limiting yourself in linear scalability. The second part, and this is all about that business agility, a very important topic that I spent the last 15 minutes talking about, is that traditional earlier gen BI platforms are based strictly on schema on write type of an architecture, and hopefully you all know what that is, and that means where data and metadata are very tightly bound, meaning that you first create your data model, and then you populate that data model with data, and therefore your data and data model are tightly bound, and the only way to change that data model is to rebuild the whole database from scratch, dropping columns, changing indices, changing primary foreign keys, et cetera, is a very difficult, doable, but a resource-intensive process in schema on write type databases. And schema on read databases, your data and your metadata are separate, and therefore you and I can have two different views into exactly the same data. So that, by the way, is why single version of the truth requires different type of handling, but schema on reads types architecture are definitely infinitely more agile. And the last couple of reasons is about bottlenecks and moving data between clients and servers, between your front-end and back-end applications. In traditional earlier gen BI architecture, no matter how scalable you make it, you're still bound by all of the traffic, all the SQL queries that are generated on your front end and go to your back-end database, and then database generates the answers to your queries and sends the result set back to your BI application. So that traffic sometimes causes bottlenecks, especially if you're sending that data across your firewall. So is there a way we can keep basically data and applications together, right, inside our clusters, as opposed to having to move the data in and out of clusters? So that's really what's behind kind of a 3 or 4 high-level use cases where big data, specifically Hadoop and Spark-based architectures, really play a key role. So with that in mind, we forced us to do a lot of research into open source technologies like Hadoop and Spark. And as you can see, the market is really embracing this type of scale-out parallel processing technology. About $800 million is being spent on Hadoop this year, and about 48% are telling us that you already have built Hadoop-based data lakes. And I'm looking at the results of the poll that Stephen, you just ran, and I do see indeed just about 50+% of people are telling us that they are piloting or have already deployed some kind of a data lake Hadoop-based BI environment. So I think the numbers differently align here. So when you look at Hadoop and Spark-based BI architecture, it carries certain implication that it's not the same as just looking at your database versus BI technical architecture. Hadoop and Spark are, very complex project. There is a huge, complex ecosystem around them. So as you're looking at these platforms, you definitely need to understand what are the data management layers, what kind of a file systems they are based on, what is the app management, cluster managers that they run on, what kind of a data processing, is it MapReduce, is it Spark or some other types of architecture, and last but not least, what kind of queries, what kind of data processing does the platform support? Is it based on SQL? Is it based on streaming or some other technologies? So with that in mind, what we did a few months ago is we ran an evaluation process of several top vendors in the space, and we looked at them very comprehensively. As you can see on the right side of this slide, we evaluated these vendors by about 15 criteria. So on the technology side, we looked at the data preparation criteria. We looked at large enterprise features such as security and collaboration, administration. Obviously, end-user self-service is a very, very important item. Data visualization, you obviously can't have BI and analytics without data visualization. SQL and all app capabilities are important, especially when you're porting your existing legacy applications to these new native Hadoop type architectures. No SQL or data discovery and exploration type operations are also important. Advanced and predictive analytics capabilities. Then Hadoop and Spark architecture, that's what I showed on the previous slide, that's what we evaluated in this particular line item. Integration of multiple components, making sure that data preparation and data visualization and self-service capabilities are tightly integrated. We looked at the deployment options on-premise, cloud, etc., and obviously we took into account customer satisfaction. We released two versions of this evaluation, one where, as you can see in the weights column, where we gave more weight to the user experience, to the user interface. And on the next slide, exactly the same model, exactly the same scores, but where we gave data preparation higher weights, because a lot of you out there kind of don't really have complex data visualizations, complex analysis, but your data, your raw data is all over the place, and you spend 80% of your time just massaging the data before you can analyze it. So that's kind of how we see the role of big data and the role of a native Hadoop distributed parallel architecture. This is how it all comes together. So Agile BI addresses end-user self-service, more business agility. Big data addresses more data availability, but also addresses agility with that schema on read type of environment. And we at Forrester now like this new term because we kind of need to describe this convergence of Agile, BI, and big data, so we now call that systems of insight. Why did we choose that term systems of? Because that is a very familiar term to most of you. You already use the term systems of record. You use the term systems of engagement, so systems of insight was just a natural way to name that. Next generation BI. Some last kind of a closing remarks on best practices. So make sure that your BI applications are not standalone. Make sure that they are tightly integrated and embedded into your operational applications and processes. That's the only way your BI apps will become contextual and they will become actionable. And definitely, and I have to admit, none of us do a good job of this continuous learning and improvement, because obviously no one gets it right from the start. So put in a set of processes and best practices that whatever results you get, whatever outcomes you get from the insights, make sure you document them, you categorize them as positive, negative, etc., and on the next iteration you'll learn and improve. So to close off, here are some high-level differences between older, earlier generation BI, where we really just concentrated on technology for the sake of technology, on a single version of the truth for the sake of the single version of the truth. Today, we clearly realize that it's not about that. That is really all about winning, serving, and retaining your customers. And we typically see that that is much better executed when a line of business executives, so CMOs and VP of sales, own BI and systems of insight environment, and where CIOs and their organization are really just supporting that environment. And that's why we at Forrester like the term business technology now as opposed to information technology, because this is technology not for the sake of information, it is technology for the sake of business results. And as you saw from my closing slides, take a look at these last best practices. Make sure that your BI environment, even if it's well architected and well-oiled and well-deployed, if it's siloed, if it's not embedded into your other operational applications, it's not pervasive, it's not contextual, it's not actionable. So with that in mind, let me turn this over to my colleagues. I think, Priyank, you are next.
Yeah, Steve's gonna jump in here and just do a quick, another poll here. Thank you, Boris, that was very insightful. So, viewers, if you're not in full screen mode, underneath of the viewing pane there, you'll see another tab pop up for just one more poll. And this question is, how do you plan to give users access to analyze their data? Option A is development tools such as Spark and MapReduce. Option B are SQL engines such as Hive, Impala, Drill, Spark SQL. C is traditional BI tools. D is Hadoop native distributed BI platforms, which Boris just spoke about. And then E, you could specify in the comments section if there's some other way you're thinking about giving access to users of your data lake or Hadoop-based platform. So just take a minute to tally the results from that. Again, it should be a tab next to where it says ask a question. There's one for vote, and you should be able to put your votes in there. And that should update in real time. We've got quite a few people on, so I'm looking for the results to stream in here. Looks like Hadoop native distributed BI platforms has the lead, but traditional BI tools is coming up. We've got SQL engines in. They're in the race as well. All right, well, just give it another couple seconds here. Votes are still coming in. Okay, so I think let's just leave that open because there's still a number of you on here. I don't want to delay the webcast anymore, but let's go ahead and turn things over to Priyank. Let's see if we can do that. All right, Priyank Patel, please take it away.
Thank you, Steve. Thank you, everyone, for attending. And I will actually jump right in and pick up from where Boris ended, which is this notion of system of insight and this push and pull that he touched upon between being agile versus having some sort of a centralized architecture which has reduction in the number of silos, not complete elimination, but silos, especially when they go to the extreme of Excel spreadsheets on every business user's desktop, do not necessarily help us as practitioners from an IT perspective. So I'll start out with a very quick introduction to how a lot of you in the audience would have seen their data architectures, right? And this starts out from data warehouses or these large-scale databases, where data from a whole bunch of sources gets combined, and from here, data moves and gets summarized into very project-specific data marts. From data marts, it moves into data BI servers and cubing engines. These are in-memory engines that summarize the data from these SQL-based data marts into another tier where it's cached in memory for actual insight and for actual usage by the end tools. Eventually, the end user, your business partner, your business analyst, or the end business user actually starts getting real access to the data. And as you see data flow through these systems, the key thing that you notice over here in the architecture is around summarization of the data, which is a requirement to fit through this pipeline. There is loss of fidelity because you lose access to the granularity of the data in the lower systems. Of course, the access to real-time data is completely not in the realm of an architecture like this. But an interesting side effect of this is a high security risk. Now you have same copies of data or same versions of that information across multiple systems, and multiple policy systems describe or controlling how security is applied to them. And then not to mention the management and operational complexity as well as the high TCO. But what I've drawn over here, as most of you are probably thinking to yourself, is extremely simplistic, even from the most early users of or even for the most simple users of these architectures. The reality is, what you find is there are hundreds of such systems. You will find this kind of an architecture replicated hundreds of times. And if you add the fact that there is shadow systems that you are not even aware of within the purview of managed IT systems, that could potentially go to thousands. And that's really where the other extreme of silos comes into the picture, whereas having agility with the help of silos is good, but not when it leads to so many copies of the data and completely unmanageable architecture. So what do you do with this? What do you do with this kind of an architecture, especially if you're trying to build a scalable system that enables and generates actionable insight, as Boris was referring to? You start out with some sort of a data lake strategy, whether you're doing it in the cloud, on-premise. You start out with a Hadoop-based data lake, and you start moving and managing a large amount of data across these different sources into the system. But what you realize as you start playing with this is that the consumption problem, the problem of consuming the data out of this lake, still remains. You still take subsets out of that, move it into the traditional systems before, after 4 or 5 layers, you get your analysts getting access to it. And what that does, especially for systems that are stuck in pilots and you've been doing long pilots for a while, is that the impression of the data lake, which started out with an important goal of being able to combine data across completely different subject areas, to a data dump, and that doesn't help how you're enabling insight out of the system, because you're still stuck with the same consumption side on the business intelligence and the analytics architectures. So how does Arcadia, with its with the technology that we develop, what do we do to address this? The notion behind Arcadia is that it's a data native architecture that lives right next to where the data lives. If it's in the Hadoop system in HDFS, we live over there. We live and run our software on individual nodes of the Hadoop system. If it's in the cloud on Elastic tiers where Hadoop is running, we run directly on the Elastic tier, do not require further copies of the data to be created. What that enables is for you to bring your business users for these use cases and your analysts directly to the data sitting on the data lake, and cut short the time it requires to move data through the different systems and to summarize the data before the end users are going to get access to it. If I blow it out a little bit and double click on how this works, a data native architecture, which is what Boris referred to as next generation agile architectures for BI, it relies on treating an underlying Hadoop system or an underlying execution engine in the cloud as an operating system. So we leverage the distributed execution that's available in the cluster. We leverage the data storage that could be stored in the file system, could be stored in object stores, leverage the metadata and the security permissions and policies that are defined over there. What you add on top of the SQL engines that are available in the systems is a data native BI compute engine. And this is an in-memory engine that is distributed. Its MPP runs on every node, and it leverages the memory of each of these nodes to provide the fast slicing and dicing that is required to enable the end users to go from exploratory analysis to editing to publishing these dashboards, reports, and eventually immersive applications or actionable applications, as I will describe, over to large numbers of users. Right, so this is really what a data native architecture does to your environment when you're thinking about enabling your business partners or your business users and analysts on data that is as high in scale as well as fast moving as generally gets associated with Hadoop or systems of insight around that. Why does it really matter? Why does it matter to actually have an architecture when you want to try to scale BI? What does the data native architecture really buy you? It is about that same pull that Boris started out and described earlier on, which is you have to bring agility from the individualized systems that end users are using and still bring it to a large scale of the data. And business agility is the key over there. You can enable users to not start out by applying these models on the data, requiring them to essentially do what is a schema on write to make it in data marts or cubes or extracts. You can still maintain that schema on read capability and enable those users to start with a simple exploratory visual interface, and at the same time have an architecture at the bottom which continuously models for performance the data that is being used. So it monitors and models the usage patterns of the system to enable fast and high concurrency access on the data. That's the first benefit, is that you bring agility back to this large scale of data and this real-time access of the data. The second is what you actually build with it, which is you take the insights that are generated, or the term that I liked from Boris was insights driven. When you drive your insights, you drive them into actions. You want to enable your business users with actionable applications that are embedded in something that they are generally consuming in the regular workflow. It starts out absolutely from the traditional production quality dashboards, but it moves very quickly into an immersive customer application that we will show some examples. It doesn't make the distinction between when the data was generated. If the data was generated in real time versus if it was available in a batch-oriented fashion, it still incorporates both of these streams right into the application. It allows you to move beyond basic charting and basic analysis and allows you to embed analysis around microsegmentation, time series, and event analytics right into the end user who can actually act upon it, act upon the insight, and drive the business forward. So let's focus first on the agility side. What does agility enable in an environment like this? Whether you're running directly on your Hadoop cluster or in a cloud cluster, the idea with agility is that you don't have to, from an IT perspective, depend on the creation definition of cubes. You don't have to do schema on write, which is essentially the definition of cubes or extracts or data marts. But you should be able to do schema on read, start out exploring the data directly, be able to do that at a large scale. Do it at the scale of hundreds of billions of records, and to enable that in a manner that your hundreds of business users are also going to get access to it. This should not be locked to the small group or the small set of advanced data scientists who are capable of using the system. How do you do that? That's really where Arcadia's architecture around smart acceleration comes into the picture. We eliminate dependence on cubes by a three-step process. If you look on the left chart over there, the system, Arcadia, sitting on the Hadoop cluster, monitors the queries that are being fired off from an exploratory perspective or from a consumption perspective from the UI. By monitoring these queries, you build intelligence, you build the right amount of information to be able to recommend the right derived forms of the raw data that should sit back in the same system. And what happens with the recommendation engine is that it automatically goes and creates these derived forms of the data that we call analytic views that are backed by HDFS, backed by the S3 storage, but that are cached in memory. So now when the queries come back again, or the reporting or the application gets consumed by a large number of users, the results are cut short by accessing these faster derived forms or these in-memory analytic views. That's the in-memory slicing and dicing that you generally associate with a copy of the data outside your system into a BI server that we bring directly to the data sitting next to the raw data. This is really where you eliminate your dependence on multiple copies of the data and enable the exact same kind of experience on a large data set and break open the kind of use cases that you can enable for your business analysts or for your end business partners to go against. Access to all data is an important aspect of agility. You don't want to limit your users to think about, is the data inside my Teradata or an Oracle or a relational system? Or is the data being accessible through an SQL engine that is native to the Hadoop system around Drill, Impala, or a Kudu, or a Hadoop-based ingestion? Or is it available through Spark, where it is being processed in real time? Or the data is available through a search-based interface, where it's either sitting in a Solr-based index or an Elastic index, or in S3 or a NoSQL system like Mongo and HBase. The idea is that you want to cut short the multiple steps that the data needs to take before it can be blended and combined for business insight and connect directly to that source of the data. That's really what drives agility in an architecture like this. The second part is around applications, which I will dig into now, which is to make an immersive application, an immersive experience that is embeddable for your end users as well. Here, you combine data from real-time as well as historical systems into the same front-end interface. How many times have you used your Alt-Tab key combinations on your machines to go between tool 1 that will do your historical charting? You go to tool 2 that gives you a little bit of access to the Hadoop data, and then you go to tool number 3, which is giving you operational real-time access to the streams. Moving between these tools is something that kills the agility, that kills the experience and the insight that the end user is trying to get. And you don't have to do that, because with the data native architecture, you get access to all the data, whether it's real time or historical, side by side. This enables use cases around connected vehicles, where you're trying to do predictive maintenance, or around real-time cybersecurity, as I'll talk about later as well. This goes towards this notion where a data lake, which starts out initially as a management tool, as a management platform to just store the raw data, is becoming more and more like a data stream. Data flows through it in real time, and some of it needs to be accessed and leveraged in real time for it to be actually actionable. Otherwise, it doesn't have much value as it becomes older in the system. The next is, reality also says that the data lake does not exist in isolation. There is data going to be in your traditional databases, whether it's Teradata, whether it's an Oracle, a Netezza system. And you should be able to blend the data. You should not be required to move all the data out of those systems of record or those traditional SQL databases before you can actually enable your users to combine that with the new streams of data that are being added into your data lake. And being able to do that cross-connection data blending is an important aspect of enabling an application experience for the end users. All this comes together when you are combining these different views into the data, real-time and historical, and building what we call our workflow-driven applications. These are web applications. They are not a single dashboard that a user is using just to get a single view into the data, but they give you multiple views into the data, one of which could be real-time, another could be historical, something else coming from the search-based side, to give you an experience that is much more immersive, and it shifts the consumption tier from what can be done merely with BI and dashboarding. This explains, or this tries to touch upon just a small set of what our enterprise customers are actually doing with the Arcadia data native platform. So I start out from companies like Procter & Gamble, where they are enabling hundreds of brand managers to understand the campaign intelligence that they are running, the digital campaign intelligence, using microsegmentation and A/B testing to understand how the brands are performing globally. Or, for example, with Newstar, where they're building and embedding this kind of an application experience into a SaaS front end that's available to their end customers for marketing attribution. Or you look at HP Enterprise, where predictive maintenance and understanding the customer usage and failure detection of the servers and of the devices out in the field is a driving factor behind using a native platform or a new architecture at that scale of the data. Going over to eBay, it talks about the usage of the same platform to drive cybersecurity analysis, the analysis of responding to insider threats, or to forensic analysis that happens when you combine data from real-time as well as historical sources. Going over to Royal Bank of Canada, you talk about using the high-velocity trade volume that they have to capture, and to combine that with electronic communication and to reduce the regulatory and the compliance fines that organizations their size are constantly faced with. Coming into healthcare side with Kaiser, their core use cases happen to be around controlling readmission risk for their patients, for the 10+ million members that are insured by an organization like Kaiser Permanente. They are utilizing the longitudinal data for these patients to understand and control the readmission risk, providing a better healthcare experience for their end customers. And the examples go beyond the slide, but these are just some representative examples across industries of what a platform or what a system of insight or a data native platform can enable if you apply the business value over to it. This is an interesting, this code just summarizes or captures in a gist what an organization like Procter & Gamble actually thinks of these distributed BI platforms. To have an on-cluster architecture is really what sets it apart from having something that requires you to keep moving data into multiple systems before consuming it. It makes a lot of sense from an architecture perspective, and as we saw earlier, it makes a significant amount of impact whether you're innovating at the front end of your business or you're trying to reduce the risk to your business, reduce the risk for your customers, reduce the risk from a security perspective. In summary, I think I want to end with this slide, which just captures the three key pillars. If you think about next-gen BI and how you scale your BI and visual analysis as these larger and scalable MPP systems are collecting more and more real-time data, you want to not fit the same model that has scaled or that has essentially gone away from agility around building these multiple copies and cubes of the data. You want to eliminate that. You want to build an actionable experience, an application that allows you to take action, not just explore the data for the sake of exploring. And do that while having a very simplified architecture that eliminates a lot of the complexity. Because it is not needed. Because it is not needed in a world where the newer architectures allow you to leverage the execution sitting next to where the data sits. With that, I will transition over back to Steve to continue.
Very good. Thanks for that overview, Priyank. So we've got some time here for the questions that have come in, and as I'm doing that here, we've also got some links to some of Boris's research, in addition to the Forrester Wave that he spoke about, some other research talking about scaling business intelligence and Hadoop-based platforms. So the first question, looks like, Boris, this might be a good one for you. In your research, you talk about and you talked a little bit today about the difference between clustered and highly parallel distributed BI. Can you spend a little more time talking about what that difference is and how it's different?
Yeah, I think the terms have definitely converged over the last couple of years, because whenever we talk about Hadoop clusters, obviously they are highly parallel and distributed out clusters. But I think in the old days, and a few people still think of clusters as basically load balancing conglomeration of nodes, where each node may be running a full set of instructions, basically the entire program, but the load balancing node just kind of distributes tasks to the least busy server, versus, as Priyank talked about, in kind of a natively architected, massively parallel processing architecture. The software natively is designed to be highly parallelized, where each node only performs its own task, right, as opposed to running the whole program. It only performs a small part of the task. And there are specialized nodes that do aggregation of the task. So basically, kind of multiple variations of map and reduce type software. So basically, at the end of the day, kind of a parallel, highly distributed architecture, has a much higher theoretical limits on how many nodes can you scale out to versus the older generation clusters.
Got it. Makes sense. Thank you. Cool. We've got a few other questions here, and if anyone else has them, please enter them in. If we don't get to it, we can follow up with you directly as well. Next question I'll ask Priyank to start on, which is, what are some of the use cases? You explained some, but talk a little bit more about needing to get access to all the detailed data. Are there other examples where that's really important?
Yes, I can actually go down into a few details that make it very clear. So let me double click into the cybersecurity use case that I mentioned, where detecting insider threats, responding to incidents in real time, and to perform forensic analysis on your networks, your users, your endpoints, is one where we're just summarizing out what is the number of incidents or threats that were in my network will not get to the root of the problem. You have to get to the individual behaviors analysis, whether they are doing whether they are browsing the network or using specific servers, and having access to the granular data in real time really matters in those use cases. Another example that I would point out is with predictive maintenance and IoT device data, where the granularity is the key. Where a certain vehicle or a truck that is sending IoT beacons back to the infrastructure, you have to be able to look at the behavior of that individual truck to be able to say whether there is some cost savings or whether there is some efficiencies to be gained by performing maintenance on this particular on that particular vehicle. That's another example on the IoT side. And on the financial services side, trade surveillance is an interesting use case. There's a lot of surveillance tools that try to catch violations in real time. But what happens is, when you try to combine this with granular communication information, around the time a trade is made, what other information is that trader having access to, and then being able to combine the actual trades that were executed with that other granular information is what enables you to catch much broader set of erroneous or potentially fraudulent behavior. And that's really an example where, again, the granularity and scale really is required if you are to get any meaningful insight out of it.
Very good examples. Thank you. Okay, I just have a minute or two left here. A couple other questions, and maybe these are quick. Can Arcadia run on cloud systems? You talked a lot about Hadoop. Can you double-click on other systems and how that works, Priyank?
Sure. Yes, Arcadia does run in the public clouds across across all the available public clouds, as well as in a hybrid environment. The way in which we work in the clouds is we are using the data native aspect of our technology and reading data directly from the object stores, from the raw stores of the data. So if you think of an Amazon environment, that would be being able to keep the data in S3 and still being able to do efficient slicing and dicing from a BI and visual analysis perspective. That's how we enable that experience in the cloud. The technology that the MPP BI technology is built so that it's parallel whether you're running it on premise or in cloud environments.
Very good. Okay. Probably one question left. Anything, Boris, that you'd like to add? I know we talked a little bit about some of the use cases for detailed data. Any other things you've thought about that you'd like to share with the audience before we do the last question?
Yeah, I think Priyank gave a great example on cybersecurity. I think definitely a lot of examples like that just in financial services when looking at end-of-day balances or any kind of aggregations will definitely not help you weed out fraud, right? So if you transferred $1 million in and then $1 million out, at the end of the day it's zero, but it's really the detailed transactions you need to be analyzing. Another interesting example that we run into all the time is when you look at a 360-degree view of a customer, your customer service interaction record may have a button check that says that this is a satisfied customer because last time you interacted with that customer at a call center, the customer was satisfied. But then when you bring in social media, over the last 24 hours, that customer may have put something on Facebook, expressing frustration with your particular product. So again, if you net both out, is that customer sentiment neutral because there was one negative and one positive? Well, neutral it doesn't really tell you the full picture. You really need to understand the root cause behind that negative sentiment from social media. So yeah, lots of examples like that.
Yeah, great examples. I'm guessing your time in financial services gives you a lot of thoughts on that. Cool. Okay, well, we're actually just a minute past the top of the hour, so there's a couple other questions. We'll follow up directly with those folks. Thank you very much, Boris, for joining us today as our guest. We really appreciate your time. Thank you, Priyank, as well, for the overview, and thank you to everyone in the audience for joining today. Hopefully you got some value and education from today, and we'll follow up with some more of this research. Thank you very much, and everyone have a great day.